Okay, before you follow these, make sure that you have looked at your notes on conditional probability and you know the formula and you know how to read the formula. So starting off with these ones. Based on the probability shown in the given Venn diagram, find each of the following. So Venn diagrams are something that you should be able to read pretty easily at this stage. So the probability of A. Now, the probability of A is the entire of A. Okay, so this entire circle. So the probability of A, you should be able to see there to be 0.6. So the 0.4, that's A only, but the 0.2 is also included in that circle A. The probability of A intersection B is the 0.2, the intersection. The probability of A union B is all three of these together, which is 0.9. And then we get into our conditional probability. So the probability here of A given that B has already happened. Okay, so B is the one that's already happened. B is the one on the bottom line that we're using. So it's always going to be the intersection on top divided by the probability that has already happened. So you're reading this as the probability of A given that B has already happened. So B is the one that I'm using on the bottom line. So the probability of A intersection B is 0.2 over the probability of B, which is the total probability of B, which is 0.5, which is 2/5. Okay. Similarly, the probability of B, given that A has already happened, in this case, I'm changing my formula slightly. So A is the probability that's already happened, so it's taking the denominator. And I'm taking the 0.2 and this time dividing it by 0.6, which gets me a probability of 1/3. Okay. The next one's just about being able to read your Venn diagrams again. The probability of A, we should be able to see here, is 0.3. The probability of A union B is 0.7. So union being everything in here. The probability of A complement. So the complement of the set is everything except for A. So the probability that A does not happen, scratch A out. And I'm looking at the probability of everything else. So the probability that A does not happen is 0.7. Okay. And the probability of A union B complement. So if none of A or any of B doesn't happen, it's the outside set, which is 0.3. So remember the complement, you might need to revise some of your set language from junior cert. So that isn't covered at leaving cert. It's expected that you know it from junior cert. So the complement is everything except for. So A complement intersection B. So everything except for A, scratch A off. So A complement. A complement, as I said, is 0.4 and 0.3. Intersection B gives you the 0.4. And finally, the probability of B, given that A has already happened. So the probability of A intersection B, given that B has already happened. Given that A has already happened, apologies. So the probability of A. So probability of B, given that A has happened. A is the one that happened, so it's on the bottom line. So 0.1 divided by 0.3. Okay, which is 1/3. Okay, two events A and B are such that the probability of A is 0.2, the probability of A intersection B is 0.15, which is already in there, and the probability of A complement, so everything except for A intersection B, is 0.6. So from the last one, we should realise that that is my 0.6. A is 0.05, okay, because we've got A is 0.2 in total. So when I add those two, I'll get my 0.2. Find the probability that neither A or B occurs. So if neither A or B occurs, the sample space, everything has to add up to 1. So 1 minus 0.05 plus 0.15 plus 0.6. Okay, when you do that, you should get, where am I gone? Sorry, you should get 0.2. Okay, right, find the probability of A happening given that B has already happened. So the probability of A intersection B, top line doesn't change, probability of B happening, which is 0.15 over the probability of B. Now the probability of B, remember, is the total probability of B, which is 0.75. Pop that into your calculator and you're going to get a fifth. It then says, is the probability of A happening given that B has already happened equal to the probability of B happening given that A has already happened? And it is not, because the probability that A has already happened, so this one, would be the probability of A intersection B over the probability of A, which is 0.15 over 0.2, which actually gets us 3 over 4. So this probability is much higher. Okay, so the probability of B happening given that A has already happened would be 3 over 4. Okay, right, going into our more word problem questions now rather than Venn diagrams. You have a certain college. In a certain college, 25% of students failed maths. So that actually answers our first part here. Okay, and generally I answer probability questions as either a decimal or a fraction. Okay, so 25% or 1/4. Okay, usually decimals are easiest, is the probability of students that failed maths. 15% of students failed chemistry and 10% of students failed both maths and chemistry. Okay, so I have 10% is that failed both maths and chemistry. Is probability of failed chemistry and maths, because they failed both of them, so they failed them together. Okay, so find the probability that a student failed chemistry given that she had failed maths. So ignoring this, because you should be able to get it yourself. So we look for the probability they failed chemistry given the probability that they already failed maths. So over the probability of failing maths, okay, which is 0.1 over 0.25, which gets me 2/5. Okay. And the next one, okay, and I've put in the cards here, okay, because it's based on cards. Okay, 3 cards are chosen at random from a standard pack of 52 cards. And then just to bear in mind here that we are choosing, okay, so we do have to keep in mind that we may have to use this. What is the probability that all 3 cards chosen are clubs? Given, so I know it's conditional probability, that exactly 2 of the chosen cards are known to be picture cards. So, probability A, let's call PA, that 3 cards chosen are clubs. So all 3 cards are clubs. Okay. The probability B then is given that exactly 2 of the chosen cards are to be picture cards. So 2 picture cards and 1 non-picture, because it says exactly 2 of the picture cards have to be, exactly 2 of the cards have to be picture cards. Okay, which means the third one can't be. So let's work with this probability first, okay? Because I know this one has happened, so it's given that this has definitely happened. So I definitely need to know this probability. Okay, there are 12 picture cards. Okay, here are my picture cards. There are 12 of them. I need to choose 2 of them. Okay, so 12 choose 2, that will give me 66 picture cards. And, okay, from the remaining 40 cards that are here, I only need to select one. So then from 40 cards, I need to choose one, which is 40. Now I need both of these to happen. I need one of these 66 options and I need one of these 40 options. So multiply and I'll get 2640. Okay. Now, this is really the cardinal number of the probability of B. So there are 2,640 possible outcomes. Okay. I don't necessarily need the actual probability here yet. Now, what I'm actually asked for, okay, so I don't actually need to find the probability of A at all. I'm actually asked for the probability of A given that B has happened, okay, which means I need the probability of A intersection B, okay, or what we're going to be using, which is the cardinal number, okay, over the number of possibilities for B. Okay, so I can use the cardinal number as well. Again, refer to your notes here as well. Okay, so that I don't have to get now I can get the probability if I want, and I can get 52 choose 3 and put it over that if I want. I just don't need to. Okay. Okay, so I don't know what the probability of A intersection B is. I do know that there are 2,640 possible outcomes for probability of B. All right. Okay. For P A intersection B, that literally means that, so I'm looking for that they are all clubs and 2 picture cards. Okay. And this is probably the most difficult bit of probability, is trying to understand the various set language and trying to understand how to piece things together. The actual maths, I'm promising, isn't going to be difficult. So, all clubs, and they have to be 2 picture cards. So, that means they have to be 2 picture cards from the clubs. Okay, so going back up here to my cards, they have to be, which is the clubs? These ones, I think. Okay, they have to be 2 out of the 3 picture cards from the clubs, if they're all clubs. So I have 3 picture cards and I need to choose 2, and I need to multiply that outcome by the third one is not a picture card, but it has to be a club. There are 10 remaining cards, okay, that are not picture cards, and I only need to choose one of those 10. Okay, so if I put 3 choose 2 into my calculator, or you might know that outcome yourself, is 3. 10 choose 1 is 10, and again, if in doubt, stick it into your calculator. That means that there are only 30 outcomes of both of these 2 events happening, of both the events that all of the 3 of them are clubs and 2 of them are still picture cards. Okay, there's only 30 possible outcomes there. So I can take that 30, bring it back up here. So 30 divided by 2,640. Now I'll have 30 divided by 2,640, and that will get me 1/88 is the chance of getting all 3 cards to be clubs if I know that 2 of them are picture cards. Okay, and just to go back to this a second, if you do understand what I meant here by the cardinal number, you can finish the video here now. That's the questions done. But if you're not sure, if I go up here and I have 52 choose 3, okay, 52 choose 3, I'm going to get a massive number. So that will be 22,100. Now, regardless of the probability, sorry, 1 extra 0 there. Okay, regardless of the probability, it'll be out of that. So I could say the probability of B is the 2,640 and then put it over 22,100. And it would be the exact same for the 30. There's 30 out of that many outcomes. Okay, but what I'll then have is I'll end up getting 30 over 22,100 over 2,640 over 22,100. And what will actually happen is the bottom probability will cancel anyway to leave you back with 30 over 2,640. Okay, so it is fine to use the number of possible outcomes when you're doing it this way, because you should be looking at it over if you're looking at it in this case, over the same number of things. So I'm still looking at both of them out of 52. Now, if one of the probabilities was that I was choosing cards and the other one was that I was rolling a dice, obviously in that case you would have to use the individual probabilities. Okay, have a look at these again. Okay.